All right, 2.6 is rational functions. And so a rational function is given this definition n over x and d over x. The end here is standing for a polynomial in the numerator, and the d of x is standing for the polynomial in the denominator. So what we have here is a rational. Some polynomial could be x cubed, could be x to the fourth, could be just x, could be a regular number, over some polynomial in the denominator. And it says that the denominator is not the zero polynomial. So in the denominator, we at least have to have a degree of 1. It has to at least be x. Could be x squared, could be x cubed. Any polynomial, as long as it's more than just a constant. For instance, x plus 5 over 2, or 2x to the 0, is not a rational function. Got to have at least x to the first in the denominator. All right, so in this chapter we're going to learn how to graph a lot of these, and for the most part we're talking about asymptotes, lines that we don't cross. So once again, asymptotes are these dotted lines that our graphs are going to get really close to, but would never actually cross. Okay, so let's take a look at our first example. We have 1 over x, and so we know from our definition that this graph should look like this if we remember our parent function of 1 over x. You could always plug it into your graphing calculator and take a look at it if you wanted to. All right, so it says discuss the behavior of f near any excluded x values once we find the domain. So once again, we're going to look for the domain. Can't have 0 in the denominator, so we should remember that x cannot equal 0. That's our domain. All right, and now so it says let's talk about the behavior of this graph, the behavior of f, as we get close to 0. So as we get close here to 0, what's happening? Well, two things are happening. One thing is happening as we come this direction from the left-hand side. Our graph is going down. But as we come in from the other side, our graph is going up. So how we're going to say this is, as x approaches 0 from the negative side, y approaches negative infinity. As we get closer and closer to 0 from the left, our y values are going down, closer and closer to negative infinity. The other way we can say this is our graph is decreasing without bounds. That means it's going down forever. And so the flip side of this is, as x approaches 0 from the positive direction, as it comes in, gets closer and closer to 0 from the right, our y values are going up and up and up and up and up. So as x approaches 0 from the positive, y is approaching positive infinity. Or we can say increasing without bounds. All right, so go ahead and take a look, if you would, at the first example here. Problem 5. So go ahead and pause this and try and solve it, and press play when you're ready. Okay, so for part A, it says complete each table for the function using our formula. So we'll start with that. So we plug in 0.5. 1 over 0.5 minus 1. We got 1 over 0.5 minus 1 is negative 0.5, so that's negative 2. 1 over 1 minus, 0.9 minus 1 equals 1 over negative 0.1, which is negative 10. And then we'll have 1 over negative 0.01, which is negative 100. And I think you can see the pattern. Negative 1,000, which makes sense here as we're getting closer and closer to 1, which is our asymptote. From the negative side, we're going down. So we're getting closer and closer to negative infinity. Okay? All right, so if we did it on the opposite side here, if we plugged in 1.5, that'd be 1 over 0.5, that's 2. And then 1 over 1.1, that'd be 1 over 0.1, which would be 10, and then 100 and 1,000. And we could keep going here on this 1 over 1,000. I'm just going to jump right to the last one here. 1 over 999. What's that getting closer to? It's getting pretty close to 0. So as we go this way, our y values are getting pretty close down here to 0. All right, so the vertical and horizontal asymptotes are part B. Our vertical asymptote going up and down is x equals 1. Our horizontal asymptote, line that we're not going to cross here, is y equals 0. And find the domain of the function for the domain. We can't cross that asymptote, so we're going to say x cannot equal 1.